Hi, this is Samuel, and I'm going to be talking about my computational photography project, where I re-implemented the laser speckle photography for surface tempering detection paper, and also explored some additional ideas. In forensics, it's pretty important to be able to detect whether an object has been touched or tampered with. But current methods like fingerprint powder can be damaging to objects, as you got to apply it physically. So, the idea of the original paper is to be able to detect tampering simply using a before or reference photo and an after or target photo. This would be impossible using regular photos under normal light, but using a laser projector, it's actually possible to detect such tampering. This is because the reflected light from a laser projector has this granular pattern um, that's caused by interference patterns, which is called speckle, and you can see that on the right. When speckle is reflected at some location, it will change even with the tiniest of deformations to the original surface. So in the diagram to the left, we can see that as soon as the surface is touched, the relative heights of x1, x2, and x3 are different, and this causes the speckle pattern to change, which changes what the camera picks up. The setup is very simple. We attach a DSLR camera to a tripod, and then tape a micro laser projector on top of the camera, setting the projector to display a pure red image. Then we can take the reference image, tamper with the surface, and then take the target image. And we can use this pair of before and after images to calculate a similarity map, which will ideally show the tampering. Once the pictures are taken, it is possible for the pair of pictures to be slightly misaligned if the camera or projector had moved slightly between shots. So we first need to realign the images so that they match as closely as possible. This is done by sampling random image patches in the target photo and then matching them to patches in the reference photo. And from that, we can get pairs of points and use that to learn a 3x3 homography that warps the target photo to match the reference photo. To calculate the similarity map at some pixel in the image, we compare the normalized cross correlation of image patches from the target and reference images, where the image patches are centered around that point. For my experiments, I first tried to replicate the main results from the original paper. The first one is the hand on the wall, which was shown previously. And the second one is drawing or writing a word on a whiteboard using just our finger. As we can see here, the similarity map clearly shows the word hi being written on the whiteboard, even though it would be imperceptible in a normal image. We also see that the system is able to faintly detect a coin being placed on a cardboard box, when again there is no visible indication of such. Beyond the experiments from the original paper, I also tried some of my own. The first was to see if it was possible to use the system when there is no pre-existing reference photo. To do this, I tried cleaning the surface to remove the oils from my hand that may be picked up in the speckle image after the surface had been tampered with, and then taking a photo of the clean surface to serve as a pseudo-reference image. But as we can see from the similarity map on the right, the white marks were simply picked up instead. I also investigated the effectiveness of the system with respect to the amount of time between the reference and target photos. In the original paper, there was roughly only a 10-minute gap between when the before and after photos were taken, but in real life, the gap would be much longer. So, as we can see here, in the 1 hour photo, the similarity map can pick up the 3 fingerprints that I left, and after 5 hours, there is still faintly signs of it. But after 24 hours, all these signs are gone. In conclusion, I was able to replicate the results from the original paper, and I also found some weaknesses with the system, such as the fact that it decays over time. But there would need to be more experiments done with this decay over time on more different materials and ideally using a better, more stable system to for it to be conclusive. And also in general, I would have liked to have more experiments done with interactions of different materials, such as more porous materials or fabrics.